Alrighty, everyone. Here's our first trial lesson during mitigation efforts. This lesson is going to pick up at the start of the IB topic 4.3. Now, we're going to break this into 2 days. One day to discuss food webs, food chains, the idea of energy transfer. And then the second day, we're going to look at it a little more quantitatively between the different levels of a food web. How much energy gets transferred from one to the next, how much is lost, why chains can only be so long, why we can't have, a consumer up at the 8th level removed from a primary producer. On with today's lesson. So on the second page, I've linked to the Khan Academy video, Energy and Matter Flow Through Ecosystems. I actually prefer the wording that energy flows and matter cycles. And they make that pretty clear in the video. But if you haven't watched that yet, please go back to the plan and click that video. Watch it. If it's helpful to take some notes while you're doing so, go for it. Don't try to make your drawings as pretty as they did unless you really want the art time. Come back to me when you've watched that video. All right. Assuming if you watch that video, I do want to clarify a couple things. Energy transformations. We still have the same old law we learned in chemistry and physics, and we've said a few times even in this course, energy can neither be created nor destroyed. However, energy is one way in an ecosystem. It's not destroyed at the end, but it is unusable at the end. Energy flows through the ecosystem. It is a one-way flow, like a river. It comes in from the sun. The energy is solar energy or light energy that is captured via photosynthesis and stored in the individual bonds of glucose. We combine the carbon dioxide and the water, making lots of new bonds in glucose. So we convert solar energy or light energy into chemical energy. We can do several different chemical energy to chemical energy conversions, but no transformation of energy is ever perfect. Every time you transfer the energy in the bonds of glucose to an energy in the bond of ATP or into the energy in bonds of some other molecule that could be broken down, we lose energy. That energy is lost as heat energy. And I say lost because living organisms cannot utilize heat energy to make ATP. We cannot utilize heat energy to make more glucose. From a biological standpoint, heat energy is a dead end. It creates a nice, comfortable environment for us, but we cannot use that energy to do work. So keep in your mind, energy flows, meaning one way, while matter cycles from one form to another, from carbon dioxide to glucose to carbon dioxide to glucose. Elements can go round and round. Energy cannot. What is the role of primary producers in this? Quick reminder of who our primary producers are back from when we did photosynthesis. We have plants, eukaryotic organisms, with leaves, stems, and roots. Then we have algae. These are your plant-like protists. They're not true plants because they don't have leaves, stems, and roots, but they photosynthesize. Many of them are single-cellular, but they can be multicellular. Then we have the cyanobacteria, as you can see in the name, bacteria. They are a type of bacteria or a prokaryotic cell. All three of these primary producers are capable of photosynthesis. This is how energy flows into an ecosystem. In the vast majority of ecosystems. There are a few weird exceptions. If you want to Google the organisms that can do chemi-autotrophism, and it's not phototropism, it's chemitropism or something along those lines, chemi-autotropism. They can utilize sulfur and heat from geothermal vents. That is a weird one for heat. Anyways, next one, food chain versus food web. As this graphic shows, a food chain you may be a little bit more familiar with, going from plant to herbivore to carnivore to the next carnivore to the next carnivore. We are seeing a single pathway that energy can flow from the original primary producer up to whatever the highest consumer it is. An organism doesn't necessarily, most organisms are not limited to one food source. So typically the better representation, although more complicated looking, is a food web. Food webs show all the different ways in which energy can flow through an ecosystem. Let's look at one food web in particular. This next one is a little complicated, but let's break it down. First, arrows show direction of energy flow. So it points from the thing being eaten to the thing that ate it, because that is where the energy is flowing to. So follow the arrow and you'll see where the energy goes. If we follow a single food chain here, we can see the primary consumer, the grass on the bottom. Its energy flows into the squirrel that eats it. The squirrel's energy will flow into the fox that eats it. But the fox will defecate or die, and its energy will flow into the decomposers. So that is one food chain that is here. You can see there are more complex ones, like the grass to the beetle to the spider to the robin, and the robin to the owl, and finally the owl to the decomposers. I love this food web because they've actually done a few things they don't normally do. First off, they're actually showing the decomposers and how they play a role in consumption of, feeding off of others that have died and waste that has been excreted or defecated. They are not typically shown in food webs, but they're an important part of cycling matter and a final way for energy to flow through the system before it is all expended as heat. This food web does not show the sun, typically not shown in food webs, but that would be the alternate source of energy that would flow in to the primary producers here at the bottom. That is all for this short lesson today. Good luck studying. Go pick one of the classwork options that I've got, and go pick one of the homework options and submit your homework option to Google Classroom. Again, a reminder that all deadlines and timelines are really just to give us a sense of normality during this distance learning. They are not required, nor are the deadlines hard and fast. Just a sense of normality if you have the time and ability to keep learning from home. All right, everyone, stay healthy and help the people around you. Bye-bye.